So for this afternoon, this will be our topic, digital modulation. This is part 1 of our study and investigation of digital modulation techniques. There are numerous. Okay, there are generally 4 types of digital modulation techniques. Dili pasabot pod nga part 1 ni siya will only be discussed. Actually, we'll be discussing only one pod out of the 4 today. But dili pasabot nga next meeting will be only the next, no? Posible. Especially sa mga more complex na digital modulation techniques, it might take us 2 meetings or pwede sa isa ka meeting, 2, no? So, ay lang na i-mind ng pag-partition ako sa pag-group na ako sa atong mga no, discussions. Okay. So, digital modulation, or in other terms, digital radio techniques, it is the modulation of relatively high frequency analog carriers. The modulation of relatively high analog carriers are modulated by relatively low frequency digital information signal. Hindi ko sure kung ma-agree ko ano nga term nga kuan, no? Wala pa na check gani award gabuhat ko. Relatively low frequency digital signal. Bali siguro ni ako na i-check later, no. Wait lang sa. Siguro ako nag-type. Wait ha. Yeah, I'm not sure kung mag-agree ko ani. First line pa. So for the most part, ang akong gigamit aning source is ang atong main reference kang Tumasi. But daghan gyapon nga parts dili gikuha nako lain-lain sa mga lain-lain pud nga sources, some sa internet. Digital modulation. Yeah, relatively high frequency analog carriers are modulated by relatively low. Kang Tumasi. Ato na naibutang dira kay mo man yung giingon, pero dili man all the time nga ang modulating signal kay low frequency. Well, in fact, bali gani dapat, no? Ano na lang, one thing's for sure, it's the modulation of analog carriers by digital information. Let's not mind na lang the frequencies, no? Kaya magbaligi dapat, di ba? So anyway, for digital modulation, the channel is either physical medium, pwede wire or fiber optic cable, or free space, pwede wireless. So bali ni siya sa digital transmission techniques. Digital transmission, physical medium lang yun, no? Walay di pwede wireless, I mean. So if this is the model or equation of our nag-zoom in lang ko sa kaninga ko formula. This is the equation of the analog carrier. So this is the equation of the carrier. So it has 3 variables. V of t, or the voltage of our carrier, is equal to the amplitude V multiplied by sine of 2t times f of t plus theta. So atong mga variables here is V, F, and theta, where V is the amplitude, F is the frequency, and theta is phase. So if we're going to use digital modulation techniques, either each of these or a combination of these ang atong ipang manipulate or i-manipulate, I mean, sa digital modulating signal para makaproduce og ang aganahang output sa digital modulation techniques is analog signal gyapon, no? Digitally modified or digitally modulated, but still analog signal. So if you're going to modulate the amplitude, it's called the amplitude shift keying. So ASK. So if ang amplitude ang ato i-modulate, that's called ASK. If ang frequency, FSK. If ang phase, PSK, phase shift keying. And if ang amplitude and ang phase, we call that one QAM, or the quadrature amplitude modulation. So the table summarizes what are the general classifications of digital modulation techniques. So these are just some of the pros and cons of each technique. For ASK, yes, it's a simple na system. Well, actually, gani, no, it might be nga ang AM modulator o demodulator, amplitude modulation tong analog bitong AM is almost the same, no? Nga system-wise or physical implementation-wise, the same lang. So it's a simple system yet very susceptible to noise. Even sa analog modulation, ang AM good ang makaproduce og more noisy nga output. The same yapon din ASK. Whereas ang FSK, it's less susceptible to noise but occupies twice the frequency spectrum than ASK. We learn more about FSK soon, and nganong mas dako nga frequency spectrum iyang kinahanglan kaysa ASK. But it is one of FSK's disadvantages. Phase shift keying, yes, it's more efficient compared to both FSK and ASK, but it occupies the same bandwidth as ASK. So lesser bandwidth. QAM, it's the most used of all today, no, mostly used and most efficient digital modulation, but it's because it's more efficient and it's mostly used nowadays. It's yung kuan is disadvantage is more complex in terms of hardware. And ang mo kuan ana, no, in effect sa atua, it's more complex pod or more difficult to understand. But more difficult compared to the others. But if makuha na natong idea sa QAM, even the basic QAM, no, sa pinaka-basic QAM, for QAM, dili gid necessarily lisod nga QAM. Lisod lang siya sa sinugdanan to understand the intuition of QAM. Again, it's important for us, yun, no, if na isa aning atong i-focus, it's QAM because mo ni siya ang commonly ginagamit karon. Even 5G will use QAM. So its application, if ASK, data over fiber ba ni dapat? Yeah, fiber cable. Yeah, sakto ASK din, no? Data over fiber cable. But maagi pagyapon na siya og kay interface or intermediary. Yeah. Whereas FSK, yeah, main application is voice lines, high frequency radio transmission, still uses FSK to some level. PSK and QAM, both are commonly used in wireless transmissions today, but more efficient yun ang QAM. So this is the block diagram of a digital modulation system. Digital modulation, okay? Specific lang ni sa kaninga mga systems. Okay, we have known last meeting the block diagram of a digital communication system. Kani is only for digital modulation systems. So basically the same na gyapon. We have the input data, we have the transmitter receiver, ang transmission media subject to gyapon to noise. So na precoder to encode, no, the data. What if the data here is analog? Okay, so i-precode gyapon siya para may mong digital pulses. Ay modulate, no, together with the analog carrier. So ang digital input o ang analog carrier, the digital input is of course digital. I-modulate siya with an analog na carrier. Then after sa modulator, moagi siya og band pass filter and power amplifier. Why nganong kinanglan moagi og band pass filter, no? Para restricted lang sa katong specific na frequency. Again, ang output at this point after the modulator is an analog signal. Okay? Even if it is digitally modulated, it's still an analog signal. So need siya ipaagi og bandpass filter and power amplifier. Kay ang kinakadakong assumption dire is wireless ang transmission, no? That's why kinahanglan power amplifier. Maybe in between sa transmission media kay nay mga antenna, no? Antenna. So the same gyapon, the same sa receiver. Inverse lang or reciprocal. Magagi gyapon ng bandpass filter, no? And amplifier. Then moagi og bandpass filter to remove the analog carrier. Parang mugawas na lang is ang digital nga output. Okay? So one thing you notice also is kaning circuit or kaning system agya po clocking mechanisms. Okay? Carrier recovery and clock recovery. Para in sync kibali ang rate sa transmission ug ang final output. So here are a comparison of digital modulation techniques or output sa digital modulation techniques. Okay? NRZ means ang kaning NRZ mo na yung atong input, no? As of karon ay lang sa siya i-mine unsa nang NRZ. Ang meaning ana is non-return to zero or non-return to zero, maabot ta na soon. Okay, basta kay mo ni ang 4, no? Ano no, 3 lagi ni wala di appeal kwam diri sa kaning kuan sa ni visual. So notice the different outputs of each modulation technique. For ASK, kabantay mo ang atong input are only ones and zeros. Okay? 1, 0, 1, 0, 0, 1. So, or high, low, low, high. Kabantay mo sa ASK, notice, if 1 ang input, na analog carrier, if 0, wala. No? So, sometimes nga gina-term ang ASK as OOK or on-off keying because if 1, on siya, mag-transmit og analog carrier. If 0, so off siya. So wala. Sa FSK, notice also that if 1 ang input, high frequency, no, ang output. If 0 ang input, low frequency ang output. Okay? Sa PSK, in phase, no, or normal nga sine wave ang output if 1. If 0, sabi niya siya, cosine, sine ni siya na 180 degrees out of phase. So, sa PSK, ang pinaka-bottom na output, if 1 in phase sa carrier, if 0, 180 degrees out of phase. Or negative, no? Kay sine wave mo ni. So far, any questions? In terms of even if wala pa nato na discuss unsang mechanism for each system or for each technique, even if wala pa takabalo sa mga equations, no? Ayan na, mga technicalities. But when it comes to this one, when it comes to the output signal, understandable na ba ang each modulation technique? Differentiate ninyo one from the other based lang sa output signal. Okay. Is it clear?
Yes, sir.
Okay, thank you, Dre. So, I hope you speak for everyone, no? Base understandable naman yun, no? It might be ganing after na to mo mahuman ang mahuman ta this semester, no? After to mahuman aning com 8. If there's one thing na di na to limtan kanino, kanigid siya. Isa yun sa mga concepts na dili lisod dinumdumon, no? Ang output signal for each modulation technique. Visual man good. So before we go further, because we'll be dealing with individual modulation techniques, overarching concepts nga i-consider for the study of each. Okay? So let's start with information theory. So due to the limited usable bandwidth available, as we all know, The amount of information that can be sent along a channel should be minimized. So the amount of information that can be sent along a channel should be minimized if possible. But most of the time, we don't want that. Kaya daghan mag i-transmit information. So, whatever ang itabo, no, whatever it is we want to achieve, the bandwidth should be used efficiently. Okay? Because again, it's important for us to know whether theoretically or practically, usable bandwidth is always limited. So the information capacity, this is the one of the concepts na ato dapat understand deeply. Information capacity is the measure of how much information can be propagated and is a function of time, meaning per second di siya. Whatever is ang na atong gamiton pag describe sa information, it's something per second. Okay, so it's a function of time. So try to think of it as a pipe, no? Pipe. Kung sa kadako or kalapad or kanipis ang pipe, mao po na ka amount of water mo flow. So yeah, liters per second man ang measurement sa liquid flow, di ba? Sa fluid mechanics. So dire, it's information per second. But information is represented by, or information is represents the number of information capacity, represents also the number of independent symbols that descend at a given time. Okay? So, maybe ang information will be described using symbols. And again, these symbols are not those symbols that we normally know. Okay? Normally, we use the word symbol to describe ka ng mga characters, no, sa keyboard, nga dili alphanumeric. So, when we say symbols in the context of digital communication, just think of it as, okay, as a type of signal. Ano lang, no? A type of modulated signal, no? Symbol. Yan na. One type of symbol is the bit. Okay, bit. More commonly referred to as bit rate, ang information capacity. So, a type of symbol is the bit. Diba? Or another way to describe information is using the bit or binary digit. So, normally, information capacity is measured in bits per second then. Okay? Because ang symbol na itong ginagamit is ang bit. And if ang information capacity is measured in time, so bit rate is bits per second. Binary digit, most basic digital symbol used to represent information. But dili lang ang binary digit, no, or dili lang ang bit ang available for us to use na symbol. But it's the basic digital symbol na gamiton, ang bit kibali or binary digit. So one metric or one phenomena that restricts information capacity is this one, no, Hartley's law. This is a physical law. Okay, sa physics ni siya nga law. Hartley's law says that information capacity is directly proportional to bandwidth and transmission time. So, yan yung na-observe ni, sabi pangalan ni Hartley. Hindi mo magawas ng Hartley. Hartley's law. Ni Shannon and ni Hartley. Lahi ni si Claude Shannon na, dili ni siya mao. Ralph Hartley. In the 1920s, I think, yan yung na-observe, no, that information capacity is directly proportional to bandwidth and transmission time. If we want to know further why this is so, we could read the paper na yung write, no, journal. But right now, we'll just accept it as is. So we have two limiting principles, or two principles that limit information capacity. One is this one, and the other is this one. The first one is the Shannon limit for information capacity, or in other terms, Shannon-Hartley theorem. Si Hartley man gid ni ang pinakauna, but gi-modify, I think, or gi-specify ni Shannon. Shannon comes later man, no, in history. So the Shannon-Hartley theorem states that I is equal to B times log base of 2, quantity of 1 plus the signal-to-noise ratio. So, no? It's easy for us to no? Understand if not the equation. Notice that the signal-to-noise ratio is unitless. No? So, if dB siya, convert na to power ratio. Everything else is in standard nga units, hertz is in hertz, and information capacity is in bits per second. So another limiting principle is, or law, is the Nyquist formulation for channel capacity. So comparing duha, this is Shannon's limit for information capacity. Ang kay Nyquist is this one. Now, why 2B? Okay. Kay Shannon is only B. Kay Nyquist is 2B, or 2 times the bandwidth. Na agiano ninyo ni sa kuan sa signals and spectra, Nyquist frequency, or lagi na nyo na concept before sa COM7, that the ideal frequency for transmission is twice the bandwidth, F equals 2B. You've heard of that before? Yes or wala pa? If wala pa, okay lang, no?
Math 89, sir.
Math 89? Di ay?
Itong sa fog.
Mo na katong tungaon nimo ang wave, sir, kay nara din limit, Nyquist limit mo na, di ba, sir?
Oo, dool na siya sa kana. Basta Nyquist, when we say Nyquist, sa communication, isa lagi ako madumduman. I-multiply lang gid ang frequency by 2, no? Yan na yung theory or yung law. Ibale ni Nyquist. So, okay la if di wala mo na familiar ni before, so don't worry. Basta kay Nyquist has stated that the ideal transmission propagating frequency is twice the bandwidth. That's why sa equation is i-multiply niya og 2B, supposed to be instead of only B. So 2B times log base 2 of M. So what is M? Before ako to answer, kay Shannon, aside sa bandwidth, depend ang information capacity or the capacity of the channel, no? Depend siya sa signal to noise ratio of the transmitting system, no? Whereas, try to remember this one, for the Shannon limit, iyahang kuan, information capacity is not only dependent sa bandwidth but also sa signal to noise power ratio of the hardware or of the transmitter. Whereas kay Nyquist, aside sa bandwidth, but it is also dependent sa M. So what is this M? M is the number of levels possible nato ni siya makuha sa modulation scheme, okay? Or sa digital modulation technique nga gi-use. Diha man nato mabalaan kung pila ang number of levels possible. All right? So when we say M, again, number of levels possible, for a binary system, M is equal to 2. Okay, M is equal to 2. Gawala man ka level. Okay, and again we define M as the number of levels possible. If M is the number of levels possible, for a binary system, the levels are only on and off. Okay, on and off, 0 or 5, or 5 negative 5. Basta kay duha ra for a binary system. For any other system, whatever is the number of symbols na possible or levels, so mo to ang M. So let's like to solve this example. I think easy na siya for you. Given given a telephone circuit using a QPSK, before wala pa man ta naka-discuss unsa gyud technically ang QPSK, but a QPSK system or a quadrature PSK. Quadrature bang meaning sa QPSK sa Q? Quarter. Yeah, quadrature day. So, hindi naman important. So, given a telephone system using a QPSK modulation scheme, QPSK meaning 4, no, ang iyang levels possible. So, given na siya. With a signal-to-noise ratio of 30 dB and occupies the 2.7 kHz bandwidth or the normal average voice channel, calculate the information capacity of the channel. Sige daw. For the next 2 minutes, kinsay makahatag sa correct answer. Kung naka-answer na mo, type lang sa chat, ha? .8 kbps. Okay. Who else has the same answer with Maui?
Ay, sir.
Yeah, and
Magamit ng 30 decibels, sir.
what do you think?
Tadadang.
Good question. Oh, good question. What do you think?
Para sa information capacity, sir, dili.
Ha? Para sa information capacity, oh.
Oh, kung information capacity lang ang gipangita, sir, dili. Pero kung mangita siya glain kay magamit.
Sure ka?
Dili, sir.
Magamit. Kung information capacity ang gipangita, magamit ang 30 dB. Of course. Karon pa kakasulod, Rex. Thanks for sa lagi ka. Namoy the same answer plus kang Maui, 10.8 kbps. Lagi, Rex. So, yun later.
Mo ko nakuha, sir, pero wala na ko gigamit ang 30 decibels.
Alright. Sige. Okay, the same plus answer ni Jenny ug ni Clark. Sige, lalahi lagi tag-answer. Kuan lagi ako 26.9.
So, lahi man ang formula.
Di mo na mong equation, sir.
Wala yung naka-formula, sir.
Uy, pareha na, IBIA, information capacity, very ipangita.
Pero wala may M, sir. Wala yung M.
Sir, na may M yatag, sir.
Kasi N.
M, sir. Kasi
Ay,
number
M.
of levels.
Okay, M.
Naman good sa pika, sir. Ang B, ana, sir. Kay save mo sa man.
Sige. Kaya mga spoilers. Sige, bitaw. So, ang A, no, first answer is this one, to use the Shannon's limiting theorem, no? So, ang kuan lang dire, key thing na buhaton is i-convert ang dB to power ratio. So, I think kabalo na mo sa pag-convert. I hope so, okay? Anti-lag sa 30 divided by 10. No? So this would get us 26.9 kbps. Okay? That is if kang Shannon nga limiting theorem atong gamiton. But the same sa inyong answer, kay Nyquist is 10.8 kbps. So, anyway, so the same sa inyong answer, 10.8 kbps, which is also correct. Okay? Inyong gigamit is 2 times 2,700 times log base of 2 of 4. So, nakuha na ninyo. So, asa sa duha to i-follow? Conclusion, each represent Uy, dili, kay Nyquist ang ang answer. Each represent a maximum rate so that the one that should be applied to this system is the lesser of the two. Nyquist, ha? Sabi, unsa agad joke ko na day mo. Sige, balik ta dire. Ang correct answer is, correct mas lang duha. But ang ato i-follow, is I is equal to 10.8 kbps. Because it's the lesser of the two. Diba make sense? If either sa duha dili the same answer, so if mag-design tag system, it would be prudent. I-solve for me ang duha. It would be prudent to use the lesser one. No? Kay kung the other atong gamiton, actually later mas masabtan pag ginato nganong dili possible or dili pwede ning kaning kang Shannon, no? Again ha, ang kang Shannon is aside sa bandwidth, nagdepend po siya sa transmission, power signal to noise ratio of the hardware. So ang capability ang capability sa system ang iyahang limit nga information capacity is 26.9 or 27,000 kbps. Okay? Nga na. But if magdepend ta sa modulation scheme na QPSK, 10.8 ragyod. Okay, 10.8 ragyod. Basta sure ko later mas masabtan pa nato di pag hindi pwede ning 26.9 kbps. But so far, is there any question sa pag-solve? Understand na ba ang both theorems or both limiting factors? Okay ra?
Murag, sir, medyo.
Sige. Sure ko ka, understand na ninyo. No? Ang akong question is pag-solve naman, no? Paggamit sa mga formula. But with that, I'm sure kuha na ninyo. Okay. So, next up is the MRE coding. So, dili na siya Mary, ha? MRE. Kung gusto niyo ibulag ang duha, so nice space between sa pag-pronounce sa M o RE. So, MRE coding generally is the encoding technique that is higher than binary, which is often more advantageous. Or it is more advantageous to use the MRE encoding techniques than just plain binary. When we say binary here, meaning it's more advantageous to use more than 2 levels, okay? So, basi makayon bitaw ta nga the same kani analogy lang ni siya, The same would gyapon sa binary system, number system o hexadecimal, no? Hexadecimal system. Diba? Kung gusto tag more efficient ang pag-use sa pag store sa information, mas better tong hexadecimal. So the same gyapon dire, no? So it's an encoding technique that uses more than 2 possible outcomes, or more than 2 possible levels, or more than 2 possible symbols. Yan na. Any of those terms are applicable. So M represents the number of conditions or levels possible, whereas N is the number of bits. Okay? So here, let's not confuse bits with binary. Okay? So ang binary again is two-level nga signal, on or off. Whereas ang bits, kasi mag-cause mo good confusions, good karon. Ano lang. So when we say binary, it pertains to the modulation technique. Whereas when we say bit, it pertains to the signal. Okay? Ano na lang siguro palilibog. Kay synonymous naman gyud, di ba? Synonymous naman gyud ang binary ug bit. Pero para dili libog, when you say binary system, it refers to the modulating technique. Whereas when you say bit, it refers to the signal graph, kibale. So to solve for the number of bits required, you just subject the number of conditions to log base 2, no? Log base 2 of m. So example, in a binary system or m equal to 2 system, 2 array, kibale, no? Binary system. The number of bits is, or bit is only 1, diba? So if m is equal to 2, log base 2 of 2 is equal to 1. So for a binary system, the two possible levels are only 1 and 0, or positive 5 or negative 5, or positive 5 or 0. So if m is equal to 2, log base 2 of 2 is equal to 1. So 1 bit lang ang pwede nga output for a binary system. Okay? Anong 1 bit lang? Because it's a binary system where there are two possible levels. So, balik sa previous problem. From the preceding problem, calculate now the number of bits needed according to the Shannon limit. Okay, kani. So, according to the Shannon limit, kaning number 1 bitaw, letter A, di ba wala na to gigamit ang M, right? It doesn't according to Shannon nga limit, wala nagmatter kung QPSK ba siya or dili. Or wala nagmatter sa tuwa pila ang number of M, di ba? Kaya ang variables naman sa equation kay B o S over R lang, S over N, no? S and R, signal to noise ratio. So if indeed the channel capacity is 26.9 kbps, pila dapat ang number of levels required for this type of information capacity? Okay. Or ani na lang, no? Just substitute 26.9 sa this equation to solve for M. Sige daw. Would like to solve. If I now is equal to 26.9 kbps, or i-round off na lang, 27 kbps, how much should be the number of levels required, M?
Pila galing tong B, sir?
Sa tunog dala. 27 kilohertz. 2.7 kilohertz. 31.59, or 32. Round up na to. Okay? Okay, discrete values man discrete levels. So 32, right? 32 number of levels. Okay, kuha ninyo ang 32, everyone. So
32 daw, sir. Plus
okay.
32.
32 flat kay 27 mo sila yung magigamit, no? 32 sarado. Katong nagamit og 26.9, I think mo tong 31 point something. So okay ra, no? Kasi kung round off mo daan sa sinugdanan, naka-round off ng answer. Diba? Sige. So basta kay nakuha ninyo, no? Nakuha ninyo ang 32. So if m is equal to 32, so dili enough ang QPSK system, no? Nakuha ninyo, if QPSK man atong gamiton, mo na siya nga 10.8 lang ang atong maximum nga information capacity. But if our system is 32, let's just say nga kuan siguro siya 32 PSK or 32 QAM, no, na by 32, na by such thing as 32 QAM. Naan ay 32 QAM. So if 32 QAM ni siya nga modulation technique, pwede pa noon, no? Mopariha siguro, no? Mopariha ang atong information capacity whether Nyquist or Shannon atong gamiton. 'Di ba? Kuha ninyo akong point. Question so far? Kaya pa? Libog na?
Fighting lang mi, sir.
Fighting. Sige. Okay ra, no? Sige lang. Kaya na, no? Pwede na natin i-review. Siguro when we go further later sa mga different modulating techniques na gyud, basing pagbalik nato ani sayo na siya sa subton. Sige lang. Okay. Another concept is the baud rate. Okay. Baud rate is the symbol rate of change in bauds per second or baud per second. So rate of change of symbol, okay, dili siya in contrast kibali to bits or bit rate. So we have bit rate and we have baud rate. Sakto bang term nga baud rate? Kaya ang baud mismo kay rate na magod siya. Yeah, baud rate. Okay. Baud na dapat na siya. So, ang difference of bitrate and baud is ang bitrate is before encoding. Okay? Before pa na-encode and before pa na-modulate. Whereas ang baud is mo ang rate of measurement sa transmission media na mismo, no? Or sa channel. Okay, kaya humana man ang encoding and after encoding and modulation. So baud is the rate of change of signal in symbols after encoding and modulation. Okay. So to illustrate that one, bitrate versus baud rate. Where bitrate is the rate at which data is sent and the unit is bits per second, bitrate is what we also use to measure the speed, di ba? Kapaspason sa transmission of data, bitrate. Baud is something different. Baud is the rate of change of the symbols, no, or the number of levels used. Let's say, for example, this one. Focus lang sa dire. So, ang horizontal line is in terms of time. No? So, in this case, we have 5 seconds. 1, 2, 3, 4, 5. So, sa vertical axis, we have 2 levels, 2 and 5. Okay, 2 volts and 5 volts. Or para simple, put it simply, ang 5 volts is si high and si 2 volts ang si zero. Okay? Is there any question sa pag-understand sa graph? Sabtan na ba? So, ang atong input is 10101. Okay? Or 5 volts, 2 volts, 5 volts, 2 volts, 5 volts. And each of the bit is transmitted 1 bit per second. That's why the bit rate is 1 bit per second, which is also the baud rate. Ang baud rate is per second man. So, nasabtan ba nga sa kaninga visual or kaninga nga image, 1 bit per second ang transmission rate, ang BPS? Is there any question? Kuha ba? It is clear nga 1 bit per second, di ba? Now, next question, okay, na-encode na. Na-encode and na-modulate. So, the output also looks like this. Okay? Let's say sa output na po nga side. Okay, output na niya siya. So, how many symbols are transmitted per second? No? How many bits are transmitted per second? One
Five.
na gyapon.
One there.
One. How many types of delete type. How many amount, no? How many amount of symbols are transmitted per second? Only one na gyapon, no? One na gyapon. So this is a baud rate of 1 baud and a bit rate of 1 BPS. Okay? For comparison ni siya, this is dali na siya subton, okay, dili kayo daghang pangutana. Now let's consider a system that has a different number of bit rate as compared to the baud. Kay kani ang baud rate o bit rate pare naman. Let's say for example ingani the baud rate is different from the bit rate. Okay. So how many bits per second do you see nga gina-transmit sa kaning scheme? How many bits per second? 5 seconds gyapon sa kaning system. So pila ka bits per second?
10.
10 bits tanan for the whole duration. Pero per second man,
5? Adi,
5?
2.
2.
2 times
Two.
5.
2. Okay. 2 times 5. Pero walay meaning sa ato diha ang pag-multiply sa 5. walay meaning ang 10 bits. So 2 siya, 2 bits per second. Makuha ninyo anong 2, di ba? For the first second, ang iyang gitransmit is 10. So that's 2 bits. So second, iyang gitransmit is 01. But that's still 2 bits. Sa third second, 10, 2 bits gyapon. Sa fourth second, 00, 2 bits gyapon. Sa fifth second, 11, 2 bits gyapon. Kuha ninyo?
Ay, sir, 1-0 din na, sir. Amin ako 10 na, sir.
Hindi na 1-0. 1-0
Sabi ko
na siya. Bago na kayo nag-digital circuits last time na.
Ito kay 10 divide 2. 5 divide 5.
Dili nga na.
Hindi ba?
Oh, sige.
Sir, big savings.
The same good gyapon sa katong hexa, di ba? Ang pagbasa nato sa 47 is dili 47 but 47, di ba? So this dili gyapon sa binary, ang pagbasa nato kay dili 10 ug 11, 10 ug 11. 00, 01, 10 ug 11. So dili dayto 10 divided by 5 nga 5 seconds, 5 volts gyud to inyong divide no. Sa ba ninyo? Sige na. Karon, at least kabalo ko nga nakasabot mo kay correct mo ninyo yung selves. Okay? So, siguro misleading ni ang 5 ug 2 sa PCAS because tungod kay we have 4 levels, we should also have 4 voltage levels dire. No? We have 4 symbols here, okay? We have 4 symbols. What are our symbols? 00, that's 1. 11, 10, 11. So, upat na sa buok. Naka-green, naka-blue, naka-red, ug naka-yellow. So, those are the 4 symbols. I think misleading ang voltage levels sa right side sa graph. Dapat kuha na siya. 0, 2, 5, ug 6 volts siguro. Kuha ninyo. Ang level 00 is 0 volts. Ang level 01 is 2 volts. Ang level 10 is 5 volts. Ang level 11 is most probably 6 volts siguro na siya. Paano niyo akong pasabot just now?
Yes, sir.
Okay.
Unta, sir.
Sige. So okay, sige, balik ko sa akong original question. For every second, makuha ninyo ako pasabot nga 2 bits per second.
Yes, sir.
Okay, good. So 2 bits per second for every second. But ang baud rate, sa kaninga system is only 1 baud per second. Because yung na-transmit per second is only one symbol. No? Even though ang one symbol is assigned 2 bits, so kuha ninyo nga lahi ang bit ug symbol. So the baud rate is still 1 bit, 1 baud per second, but the bit rate is 2 bits per second. Now, each signal represents 2 bits as compared to earlier. Yes, sa kaninga scheme nila, sa kaninga example, one symbol is 2 bits. Sa kaninga example, one symbol, 1 bit. So if 1 bit per second and one symbol, 1 bit, ang baud is 1 baud per second.
Na kay example, sir, nga mahimong duha ka symbol per signal.
Duha ka symbol per
Adi, like, di ba kani, sir, kay
duha ka symbol per
2
second.
bits, 1 signal? Ay,
2 bits, one symbol.
kano sa siya 2 symbols, sir? Or possible ba na?
2 symbol. Kuan. Dili, ang question diha kay if duha ka symbol, nahiman siya nga quantity, ang mobile ka sa question nga pila ka bit ang per symbol. Kay per symbol man ang atong kuan noon, ang atong gina-focus dili man nun example natay 5 ka symbol. Mobile man gyapon sa question nga pila ka symbol, pila ka bits per symbol. So di naman sila mag-matter kung pila ka symbol per second. But ang question is pila ka bits ang gina-represent sa isa ka symbol. Yan na gyapon ends.
Yes.
Yes. Sige lang. Siguro as of this time for introduction of terms lang siguro sa nino. The same song yung ganiha. The more deeper the more mas dagan atong ma-tackle nga modulation techniques na gid mismo. All the more masabtan nato ni nga mga terms, baud ug bit. Okay? Mga symbol, bits, binary yan. Basig na overwhelm na bitaw sa kadaghan sa terms na itong ginagamit. Sige. So, balik ta sa akong original nga slide. Based ato nga kuan and in concept, in binary systems where m is equal to 2 and n is equal to 1, BPS and baud are equal. Okay? So, remember this one ha. In binary systems, BPS and baud are always equal. What are examples of binary system? ASK and FSK. So ASK and FSK are both binary systems, meaning 2 levels. So their baud and BPS are equal. Whereas for higher MRE systems, where M is greater than 2, BPS is usually greater than the baud. The same aning kaning example. No? Kuan man eh. So for possible symbols man eh. Okay? 4 possible symbols. 0, 0, 0, 1, 1, 0, and 1, 1. So if this is M equal to 4, it might be that this system is a 4-QAM or QPSK. Nalaana. Remember lang ni. Okay? Just remember this one. Kaning final 2 lines. In higher MRE systems, BPS is usually greater than the baud. Okay, before we end, ato lang sa ning i-introduce ang the first of the digital modulation techniques, the ASK. So it's a very simple modulation technique. It was used in wireless telegraphy about a century ago, but is now used in fiber optic communication, where the light source is turned on when bit is 1 and turned off when bit is 0. Ito ba? Basically, ang fiber optic man dahil nga kuan kay in essence, although not in actual na implementation, but in essence, ASK man gid gyapon ang kuan, ang fiber optic na communication. At least na po ko na learn something new. The carrier wave is turned off and on and off every period of seconds to represent 1 or a 0 respectively. Thus is also known as on-off keying. So this is the formula for the output of an ASK nga modulating technique. 1 plus the voltage level, Vm, times A over 2 times cosine omega C of t. C times t. So, focus lang sa equation. Okay, focus sa equation. For a digital system, again, for a binary system, how many levels do we have? Binary? 2. Okay, very good. 2. So, I'm going to assign 2 voltage levels for our binary system. Okay? For the off, we'll use 0. And for the on, we'll use 1 volts. Okay? So, if 1 ni siya, if 1 ang VM, if VM is equal to 1, ano sa output? 1 plus 1 is equal to 2. So, makancel siya sa 2 sa PCAS, no? Sa A cosine, A over 2 cosine omega t. So, if ang atong input is 1, 1 plus 1 is 2, cancel siya sa 2 sa cosine. So, ang output is A cosine omega t. Or whatever is the value of A times cosine omega t. So, cosine kuan lang, cosine wave. Di dapat 0 ang akong i-assign, no? Di dapat 0 akong i-assign sa VM kung off. Negative 1. So, if negative 1, 1 plus negative 1 or 1 minus 1, the output voltage is 0. Okay? So, if on ang kuan, no. If high ang input, output is A cosine theta or A cosine omega t. If low ang input, output is 0. So, dahil na siya timandaan. And ang itsura sa atong output graph is ingani. Okay? So, if high, may cosine wave. If low, 0. Off. Ingana lang. Understand? Sabtan nyo, guys? So we could assign A as 5, no? Para sa output. Okay, pwede Ranil. So if we could assign A as 5, ang output ani, this is 5 volts and 0 volts. And pwede na nato i-assign ang modulating signal as 1 and negative 1, no? Sa input kibali bitaw. For this to work, no? For this equation to work, ang levels sa atong input should be plus and minus 1. No? Sabtan ninyo anong plus and minus 1 dapat? Kung plus 1, may mo maning 2. So, ang output is A cosine theta. But if negative 1, 1 minus 1, so 0 ang output. Yan na. Ako nang patong ibutang sa dapat, no? Pero, i-remember na lang to siya. No? Anyway, arbitrary naman sad. Arbitrary naman sad ang assignments, no? Assignments sa voltage levels. All right? So ASK pa noon eh. If dili ra kay challenge for us ang pag-understand sa equation sa ASK. At least na atay foundations pag-understand po nato sa equations sa other digital modulation schemes like FSK, PSK, and QAM. So, kaya mag-refer magyapon ta sa equation before ta mag-refer sa system, no, or sa hardware. All right?